All right, so now we're doing applications. So remember, when finding time or distance, we will always need to choose the appropriate sign for the radical. So in hint, we need the positive only in this case, because if we can't have a negative time after we've dropped something, because that would be some other time, or we can't have a negative height in the matter we're looking at it. And so we always have to have those positive ones. All right, so we have an object drop from a height of 600 feet, and that's going to be ht in feet after t seconds have elapsed. And so this is our function. Express t as a function of h. So we need to solve this for t and make it th instead. So what we're going to do is I'm going to rewrite this as y. Well, maybe we should put it h and t's instead. That would make it so we don't have to do too much different. Okay. So let's say we have h equals 600 minus 16t squared. Now we're going to solve for t, so let's subtract 600. So h minus 600 equals negative 16t squared. Now we're going to divide by a negative 16. All right. And so then we can do several things. We can say, well, that's now equal to maybe 600 minus h over 16 equals t squared, or we could leave it as it is and do that. But that way we have our positive out in front, and that's kind of how we have it here. We have positive here, now we have the positive here, and that's positive as well. Now we need to take the square root of that to solve for t. And again, when we have t, we need only the positive times because it's going to be a time in the future. We don't want the time in the past, okay? And so then t is equal to the square root of 600 minus h over 16. And if we write that as a function, that's going to be t of h equals the square root of 600 minus h over our 16. Okay, now we could go ahead and take the square root of that, and that would be 4. And so that would be the square root of 600 minus h over 4. And that might be the most simplified form that we could do now. Now it says, find the time to reach a height of 400 feet. Well, that says find t of 400. So we just say, okay, well, that's the square root of 600 minus 400 divided by 4. And so if we do that, 600 minus 400 and then divided by 4, we get 3.535. So we'll call it approximately 3.54 seconds. Okay, so that would be the time. And we really, it says find that function as expression of height. So that would be, we could do either one of those, whichever one we feel comfortable with. I think this one, we can simplify the most to here. So that was a good one. And then we just plugged it in and we got our 3.54 seconds. Now let's go ahead and go on to the next one. It's not too bad. We can simplify it. And it basically says we have a period t in seconds of a simple pendulum as a function of its length L, and is given by this. So it's basically L over 32.2, take the square of that times 2 pi. What we want to do is solve for L and express it in terms of t. So let's do that. L over 32.2. Well, we need to solve for L, so we'll have to divide both sides by 2 pi. So we'll take 1 over 2 pi here and times 1 over 2 pi here. So t over 2 pi equals square root of L over 32.2. Now we need to get rid of the square root. So we'll square both sides. And so when you do that, that's going to be t squared over 4 pi squared. That's equal to L over 32.2. Now what we need to do is multiply by 32.2 on both sides. And so then we have that cancels that. Now 32.2 divided by 4. Okay, we could reduce it, but I don't know how useful it'll be. And we get L of t is equal to 32.2 t squared over 4 pi squared. Okay. Now, we could do it, and like I said, we could have reduced it, and that was going to be 8.05 t squared over pi squared. Okay, so that would be the reduced form. We could leave it as this. We could divide by only 2, and that would be our 16.1. Where do you stop? So, one of these two is going to be our final function as L of t. And then they want it as a period of 2 seconds. So they want L of 2. Well, if we do this one, it makes it a little simpler. So we just have to take 8.05 times 2. Well, actually, it's be easier on this one because what happens is that's going to be 2 squared. Now it's over pi squared. So if we'd had 2 squared here, they cancel 4 and 4. And we just have 32 divided by pi. Here we just have 8.05 divided by pi squared. So either way, we're going to get a same answer. So 8.05 times pi squared, and we get 3.263. So we'll call it 3.26, and our units are in feet. So feet. So that is going to be our express L as a function of t, which is one of those two. And the length of the pendulum is that with the period of 2 seconds. Okay. All right, so let's stop there and we'll come back for one more.